Okay, let's start with chapter number 3. So what were the last topic that we have completed? The last topic.
So we finish average velocity.
Finished average velocity. The next is acceleration. After average velocity, the next is acceleration. No, we haven't done instantaneous velocity yet, right?
No, sir.
The next is instantaneous velocity.
Yes, sir.
Instantaneous velocity. So it's just like instantaneous speed, only the difference in direction. So instantaneous velocity is velocity at a particular time instant. Okay, did you solve that assignment? Assignment that I gave you on Monday. Noor, Sania.
No, sir.
Not.
No, sir. Not complete.
So only 7 or 8 questions in that assignment. See,
Sir, I
what time
did
to
have.
sorry,
I did only 2 questions.
did only 2 questions. Try to solve the assignment on the same day. Otherwise, it would be backlog. I will
Okay, sir.
assignment of acceleration today, so you won't get time for the last assignment. So velocity at a particular instant of time is instantaneous velocity. So this is instantaneous velocity, which is velocity at a particular time instant. So just like instantaneous speed, you can simply write your instantaneous velocity as dx over dt. The only difference is here direction is involved. In speed, there was no direction, but in instantaneous velocity, it's a vector quantity, so direction is involved. Okay, just note it down, then move on to next topic. Note it down, then we will move on to next topic.
That's it.
Okay. Sania?
Done, sir.
The next is acceleration. Acceleration is simply rate of change of velocity. Acceleration is rate of change of velocity. Rate of change of velocity is known as acceleration. So you can simply write that acceleration is change in velocity over time. This is acceleration. Or you can simply write this as delta V over delta T, change in velocity over time. So just like velocity, your acceleration is a vector. Its SI unit is meter per second square. Its SI unit is 2 meter per second square. So that's acceleration, which is a vector. Acceleration is rate of change of velocity. Its SI unit is meter per second square. Now, just like velocity, your acceleration could be uniform or non-uniform. The acceleration of body, it can be uniform. Body can move with uniform acceleration, or acceleration could be non-uniform. So you can have following 2 types of accelerations. One uniform acceleration and another non-uniform acceleration. So just note it down, then we'll start with uniform acceleration. And one more thing, if you have non-uniform acceleration, then you can measure it in two ways. Either you can measure as an average acceleration. You can either measure this as an average, or you can measure this as instantaneous. Okay, just note it down. Fazil, we just have started acceleration. Just note it down, please.
Okay, sir.
Okay. So shall I raise it, Fazil?
Yes, sir. I have taken
Okay.
screenshot.
You're taking screenshot. Say uniform acceleration. See, when I say that your body is accelerated, motion is accelerated, that means velocity is changing. If motion is accelerated, that means your velocity keeps on changing. Your velocity cannot be constant. So uniform acceleration means, and if I say velocity acceleration is uniform, that means your acceleration is constant. It does not change with position or time. It's better to write uniform acceleration means it does not change with position or time. So if acceleration does not change with position or time, then your acceleration is uniform acceleration. Or there's one more definition of uniform acceleration. If velocity change uniformly, means if velocity change by equal amount in equal interval of time. So if velocity change by equal amount in equal interval of time, then acceleration is uniform. So velocity change by equal amount means, let's say this is t equal to 0 instant. At t equal to 0 instant, velocity is 2 meter per second. Then this is t equal to 2 seconds, your velocity is 6 meter per second. Then this is t equal to 4 seconds, and your velocity is now 10 meter per second. Okay, if you check, say this 0 to 2 seconds, that means the time interval of 2 seconds. In the time interval of 2 seconds, your velocity changed from 2 to 6, means your velocity changed by 4 meter per second. In the next 2 to 4 seconds, again a time interval of 2 seconds, your velocity changed from 6 to 10, it again changed by 4 meter per second. So if velocity changed by equal amount in equal interval of time, then you will say that your acceleration is uniform. If I calculate acceleration in this way, so this is change in velocity, which is 6 minus 2. Over time interval, that's 2 minus 0. So it's 4 by 2, that's 2 meter per second. Similarly here, velocity is changing from 6 to 10. So that's 10 minus 6 over 4 minus 2. It's 2 by 2, which is again 2 meter per second square. So if your velocity changes uniformly, then acceleration is uniform. Sania, if velocity is constant, then acceleration is
0.
good.
Cons.
Then acceleration is 0. Okay, just note it down, then we'll do non-uniform acceleration. So can I erase it?
Yes, sir.
Yes, sir.
After uniform acceleration, the next is non-uniform acceleration. Non-uniform means simply variable acceleration. Non-uniform means a variable acceleration. If your acceleration is variable, then it is non-uniform. Velocity changed by unequal amount. Velocity change non-uniformly. If your velocity is changing non-uniformly, then your acceleration is non-uniform. Non-uniform variation means, let's say this is t equal to 0. Your velocity is 2 meter per second. The next time instant is t equal to 2 seconds. Your velocity is 6 meter per second. The next time instant is t equal to 4 seconds. Your velocity is 12 meter per second. So your velocity is changing non-uniformly. In first 2 seconds, your velocity changed by 4 meter per second. But in the next 2 seconds, your velocity changed by 6 meter per second. So the change is non-uniform. If change is non-uniform, then acceleration is variable. Say in this case, acceleration is 2. What was the acceleration in this case? 12 minus 6, 6 by 2, 3 meter per second. So if your velocity changed non-uniformly, then you would say that your acceleration is non-uniform. The case of non-uniform acceleration. Now, if your acceleration is non-uniform, then you can measure it in two ways: average or instantaneous. Let's see first what is average acceleration. Average acceleration is simply the difference between final velocity, initial velocity, divided by timing. For average acceleration, just need the difference in final and initial velocity, which is delta V over delta. For example, if I take the same example, this one, it's 2 meter per second, 6 meter per second, 12 meter per second. Time instant is 0, time instant is 2 seconds, time instant is 4 seconds. Okay, Noor, what should be the average acceleration in this case?
So 10 by 4.
10 by 4. It's delta V by delta T, which is final velocity minus initial. So final is 12, initial is 2. Final time instant minus initial. It's 14 minus 8. It's 10 by 4, which is 2.5 meter per second square. So whenever we calculate average acceleration, we just worry about the initial and the final velocity. Only initial and final velocity matters. In between velocities, in between initial and final, does not matter while calculating average acceleration. Is it clear, Fazil, Sania?
Yes, sir.
Okay, just put it down. Then we'll do one more example of on average acceleration. Robert,
Yes, sir.
Fazil, Noor.
Yes, sir.
Yes, sir.
Let's solve this question. A car moving with speed of 20 meter per second takes a U-turn in 2 seconds and continue to move with same speed, means with 20 meter per second. Calculate average acceleration. Though diagram is not given, but I'm drawing it. Like say, this is moving in this direction. Then it take a U-turn. It's moving in this direction with 20 meter per second. It takes a U-turn, and after U-turn, it continues to move in the opposite direction with the same speed. And the time taken in U-turn is 2 seconds. So what do you think? What should be the average acceleration? What should be the average acceleration in this case?
minus 20
Minus 20.
meter per
0.
Minus 20.
Minus 20. Okay. Yes. Not zero, Sani. See here, speed is constant, but velocity is changing. Velocity also depends upon direction. Initially, this is the direction of velocity. And then this is the direction of velocity. Direction of velocity is changing. So due to change in direction of velocity, your system will have some acceleration. It's v final minus v initial by time interval. If I say that initial velocity is 20 meter per second, then your final velocity is minus 20. Because velocity is a vector, if I'm taking the direction to the right as positive, then direction to the left is negative. If I substitute it here, then average acceleration is minus 20 minus 20 by 2 minus 40 by 2.
2,
It's
20.
minus 20 meter per
20 per second.
This negative sign here shows that direction of acceleration is opposite that of initial velocity. Initial velocity, also known as retardation. This is also known as retardation. This is also known as retardation. Okay, just note it down. Fazil, Sania, shall I raise it?
yes sir
Yes, sir.
So is it clear, Sania? Sania, it won't be zero.
Yeah. Sir.
Because whenever velocity change, you will have some non-zero acceleration. If acceleration is zero, that means velocity is not changing. Velocity not changing means neither magnitude nor direction is changing.
Yeah.
Okay, let's erase it and move on to instantaneous acceleration. Sani, can you guess how would we calculate this instantaneous acceleration? We have done instantaneous velocity, instantaneous speed.
Delta V by delta T.
That's average. Just checking instantaneous speed, the steps we have done in instantaneous speed.
Delta S by delta T.
Next step. So average acceleration could be written as average acceleration A is delta V over delta T. For instantaneous acceleration, we always shrink the time interval. For instantaneous acceleration, we just shrink this time interval. So we can just write this as that average acceleration is limit delta t tends to 0. It's delta v over delta t. We can write this delta v over delta t as dv over dt. So for instantaneous acceleration, we just have to shrink the time interval. So this is instantaneous acceleration dv over dt. Means you have to differentiate velocity with respect to time. That's instantaneous acceleration, rate of change of velocity with time. You can even write your velocity as your velocity is dx over dt. Velocity is dx over dt. So if I substitute dx over dt instead of velocity, this is d over dt of dx over dt. And this dx over dt is, your acceleration is d square x over dt square. It's d square x over dt square. This is how we calculate instantaneous acceleration. Is it clear?
Yes, sir.
Yes.
Just please note it down. So this is known as second derivative. Means you are differentiating position twice. This is first derivative. You are differentiating velocity one time.
Done, sir.
So can I erase it?
Yes, sir.
Okay, after instantaneous acceleration, do one numerical. Velocity of body change with respect to time as this is the expression of velocity. Velocity is 3d square plus 2t plus 1. Calculate first part. Acceleration in 0 to 2 seconds. Second, acceleration at t equal to 2 seconds. Calculate. Calculate value of acceleration in 0 to 2 seconds and acceleration at t equal to 2 seconds. We have done a similar question on average velocity and instantaneous velocity. Answers? Answers?
Sir, second one is 40.
Second one is 40. 40.
Oh, 14,
This
1
one
4.
is 8 meter per second.
Just report your answer in chat room. That would be easy. Sania, Fazil, Noor, just report your answer in chat. Okay, so that's answer of first part, Fazil.
Yes, sir.
Sania, your answer. Okay, what about the first part?
Sir, I'm doing.
Noor, this is first part, huh? 8 meter per second square. Yes, Noor, both are correct. Yes, Fazil, both are correct. Sania, second part is correct. Let's try first one. Average acceleration is change in velocity, huh? Over time. Yes, Sania, it's correct. So we can simply write this as V2 minus V1 by T2 minus. So here T1 is 0. So your V1 is 3 into 0 square plus 2 into 0 plus 1. So V1 is 1 meter per second. Your T2 is 2 seconds. V2 is 3 into 2 square plus 2 into 2 plus 1. V2 is 12 plus 4, 16 plus 1, 17. It's 17 meters. So average acceleration is, it's 17 minus 1 by 2 minus 0. So it's 16 by 2, which is 8 meter per second square. This is the average acceleration. In the second part, at t equal to 2 seconds means instantaneous. Instantaneous is simply dv over dt. So instantaneous is d over dt of 3t square plus 2t plus 1. So instantaneous is 3 is constant, derivative of t square is 2t plus 2, derivative of t is 1 and derivative of 1 is 0. So your acceleration is 60 plus 2, just put t equal to 2 here. So acceleration is 14 meter per second. So is it clear? So all were correct.
Yes, sir.
Writing it or can I raise?
So we already wrote.
Sania?
Yes, sir, done.
Okay, so let's erase it. The next is uniformly accelerated motion. The next topic is uniformly accelerated motion. Uniformly accelerated motion means motion with a uniform acceleration. If acceleration, this one more concept, this one more small concept. There's one more concept of velocity. Retardation. Retardation means negative acceleration. Retardation means negative acceleration. So negative acceleration means acceleration is acting in a direction opposite to that of velocity, which means direction of acceleration is opposite to velocity. The direction of acceleration is exactly opposite to that of velocity. Means if body is moving in this direction, then acceleration is in opposite direction. Acceleration is in opposite direction, that means force is in opposite direction. So what will happen if you apply force in a direction opposite to that of velocity of the body? Its velocity will increase or it will decrease?
Decrease.
If you apply force in a direction opposite to that of velocity, that means its velocity will decrease. The velocity will decrease. Okay, just note it down and rub it. Okay, let's start with uniformly accelerated motion. Uniformly accelerated motion. So uniformly accelerated motion means motion with a uniform acceleration. Motion with uniform acceleration. If acceleration is uniform, that means your motion is uniformly accelerated. If your motion is uniformly accelerated, then you can use following equations of motion. So if acceleration is uniform, null, what does it mean? It means velocity is constant or variable.
So velocity is variable.
Very clear. Velocity is variable. So if your velocity is variable, then in this type of motion, you have some parameters. Like you have one displacement, you have one parameter time, you have one parameter which is initial velocity, you have a parameter which is final velocity, and then displacement. You need an equation which can connect all these parameters. So if a body is moving with a uniform acceleration, so to explain the motion of body, to describe motion of body, you need certain parameters. Those parameters are initial velocity, final velocity, time, displacement, and acceleration. So these are following 5 parameters. Parameters for uniformly accelerated motion. Uniformly accelerated motion. For uniformly accelerated motion, we have following parameters. The first parameter is u, which is initial velocity. The second parameter is v, which is final velocity. Third parameter is acceleration, which is constant. It doesn't change during motion, it's constant. The fourth parameter is displacement. And the fifth parameter is time. So for a uniformly accelerated motion, to study uniformly accelerated motion, you need following 5 parameters: initial velocity, final velocity, acceleration, displacement, and time. To relate these parameters, we write 4 equations of motion. The first one is v is u plus at. The second one is ut plus half at square. This relates velocity, acceleration, and time. The third one is v square minus u square is 2s. There's one more equation which is dn is u plus a by 2, it's 2n minus 1. And just one more thing. Here average velocity is v plus u by, this is average velocity. This is how we can calculate average velocity. Here dn is displacement covered in nth second. dn is displacement covered in nth second. We will discuss about dn at the end. First we will do numericals on these three equations only. Then we will, at the end, we will discuss what is dn, what does this equation means. Okay, just note it down. Sania, Fazil, can I erase it?
Yes, sir.
Yes, sir.
Yes, sir.
We will derive these equations, but after numericals. First, we will solve numericals based on these equations. And once you are used to with this equation, then we will derive it. So I'm starting with a very basic numerical. It's simply a formula-based numerical. This will teach you how to use these equations. A body starts from rest and accelerate uniformly at, the first numerical is simple formula based, 2 meters per second square. Calculate first part. Velocity of body after 2 seconds. Displacement covered in 2 seconds. Third is velocity when it have covered displacement of, let's say, 20 meters. Solve it and report your answer in chat room. And write all answers together. Write all three answers in one section. Report all answers together. The straight formula based numerical. Okay, Fazil? Okay. Okay. Sania, your third part, answer of third part. Okay, now let's check your calculation. Here, initial velocity is 0. If it starts from rest, that means initial velocity is 0. Acceleration is 2 meter per second square. You need all quantities after 2 seconds. So the first part. Velocity of body after 2 seconds. So use this equation. V is u plus at. U is 0. Acceleration is 2. Time is 2. So your velocity is 4 meter per second. That's first equation. Then equation number 2. Displacement covered in 2 seconds. It's ut plus half ad square. It's 0 plus half acceleration, which is 2 into 2 square. So it gets cancelled out. So the answer of second part is 4. Third part. In third part, there is no information of time. When you don't have any information of time, so it's better to use this equation. V square minus u square is 2s. So your v is unknown, u is 0, acceleration is 2, and displacement is 20. So your v square is root over 80 meter. V square is 80 over. So v is root over 80. Sania, is it clear last part?
Yes, sir.
So Noor, Fazil, all 3 parts was correct. Sania, your first part was correct. You haven't calculated the third one, Sania?
No, I was getting wrong.
Okay. Yeah, the third
Like
part.
I got 80, then I did not get root.
Okay, got 80.
Sir,
Yes, Fazil.
sir, are we supposed to reduce it, like simplify root 5, or
Yeah, that's not an issue. You can leave it over root 80, or if you want, you can just simplify it like this will be a square or something. Na? This is 4 into 20. That will be 6.
4 root 5?
Right. Even if you leave this answer over here, you want no one will deduct any marks.
Okay.
So that was a straight formula based numerical. This is just how to use the formula. So Sania, can I erase it?
Yes, sir.
Now try to solve this numerical. This was even in your, maybe in your school exam, or yeah, it was in your school exam last year. 0.2 seconds to apply the brakes after he sees a need for it. This is called the reaction time of driver. If he is driving car at a speed of 54 kilometer per hour and brakes cause a deacceleration of 6 meter per second square. Deacceleration means retardation. Take this as negative. Find distance traveled by car after he sees the need to put the brakes. Okay, solve this numerical and report your answer in chat. You have 3 minutes for this numerical. Answers. .8 meter, 4.2 meter. Okay. No, Fazil, Noor. It's not correct. Sania, your answer? You're not even trying, huh? Sania, are you trying? 1.7. See, okay, just check your calculations. So a driver takes 0.2 seconds to apply the brakes after he sees a need for it. Say this is a car. This car is moving. And say this is the child. This is car. The driver of the car see this child at t equal to 0. You see this child at t equal to 0. He decided, okay, we have to put the brakes just to avoid accident with the child. But he can't apply the brake instantaneously. This is what actually happened in driving. He watched this child or sees this child at t equal to 0. But to apply brake, it takes some 0.2 seconds. He applies brakes in t equal to 0.2 seconds. After 0.2 seconds, he applies brake. So here to here, the acceleration of car is 0. Means in 0 to 0.2 seconds, there is no acceleration. Because car will deaccelerate only after the driver applies the brake. Here, car is moving with a velocity of 54 km per hour. After 0.2 seconds, the driver applies the brakes and the acceleration of car is now minus 6 meter per second. And finally, the car stops and the final velocity of car comes out to be 0. Car just stopped just before the child. So the final velocity of car is 0. So I'm repeating the question again. A car which is moving with a velocity of 54 km per hour, the driver of the car at t equal to 0 see this child. He decided to put the brakes, but he applied brakes after 0.2 seconds. This is known as the reaction time. This 0.2 seconds is the reaction time. Once he put the brakes, the car deaccelerates. The deacceleration is minus 6 meter per second square. And then finally this car stops. So he's asking you to calculate the total displacement. This is S1. The displacement covered by the car till the brakes are applied, and after the brakes are applied, the displacement is this. To solve these type of problems, is this question clear? Sania, Fazil? No.
Yes,
Yes, sir.
sir.
Let's say this is point A, this is point B, and this is point C. Let's first consider motion from A to B. If I'm considering motion from A to B, your initial velocity is 54 km per hour. This could be converted into meter per second, multiplying by 5 by 80. So 18 threes are 54, that's 15 meter per second. Sania, what is the acceleration of car from A to B?
Minus 6.
When did it apply brakes? In between 0 to 0.2 seconds or after 0.2 seconds?
After 0.2 seconds.
So what should be the acceleration in between 0 to 0.2? If he have not applied brakes, then velocity of car will not change. The acceleration would be 0.
0.
Okay, and time, what's the time taken from A to B? This is A and this one is B. How much time will car take to travel from A to B?
0.2.
0. UT plus RV. So the displacement that this car will travel, cover is 15 multiplied by 0.2 plus 0. I call this as S1. So this is 3 meters. So this is the distance that car travel before applying the brakes. Now, at t equal to 0.2 seconds, driver applied brakes. So the initial velocity is 15 meter per second. It's 54 kilometer per hour, it's the same speed here. It's 15 meter per second. In between 0 to 0.2, there is no acceleration, so velocity will not change. So what about the acceleration now? Sania, after 0.2 seconds, what is the acceleration of the car?
Minus 6.
Minus 6. And what about the final velocity? Sania, if cars, then
0.
I have to calculate displacement during the interval when velocity changed from 15 to 0. Can you suggest an equation, the appropriate equation to calculate displacement? Which equation would be most appropriate out of the first three to calculate displacement in this case? Sania, first, second, or third?
Third.
Why? Why not first or second? Why not first or second? First is
Because the time is not there.
time is not there. So v square minus u square is 2s. So v is 0. Your u is 15 square. Your acceleration is minus 6. Your displacement is s2. So it's 0 minus 225 is minus 12 s2. So this negative will cancel this negative. Your s2 is 225 over 12. It comes out to be 12 1. 105. 12 7 is 84. So 96. 72. S2 is 18.75. So what's the total distance that car traveled? Total distance?
3 plus 18.
Yes, the total displacement covered by car is 3 plus 18.75. which comes out to be 18, 19, 20, 21, 21.7. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Just note it down, then we'll do one more numerical on the same concept. Just let me know when you have written it.
Done.
Yes, sir. Done.
Yes, sir. Done.
Okay, let's erase it and start next one. A motor car starts from rest. Starts from rest means initial velocity is 0.
Yes.
And accelerate
Will be negative.
you're writing even question, na?
Yes, sir.
Yes.
Yes, sir.
Don't miss the question, otherwise
Yes.
solution will not make any sense. Each and every numerical that we are discussing in class it's important for even for your school exams. I'm just modifying the syllabus as per your parents' school exam. Okay, just note this numerical and try to make a rough sketch. We will solve this numerical together, but at least make a rough sketch of the given data. Just make a rough sketch of the given data. Okay, let's start this thing together. So a motor car starts from rest. Say a car starts from point O and velocity at point A is 0. Is 0. And accelerate uniformly for 10 seconds. Let's say travel up to point B. The time taken to travel from A to B is 10 seconds. Acceleration from A to B is not given. But when it reached point B, its velocity is 20 meter per second. At B, its velocity is 20 meter per second. It then runs at a constant speed. So from B to another point C, it runs at a constant speed. It runs at a constant speed of 20 meter per second. From B to C, it runs at a constant speed, fairly constant speed of 20 meter per second. Time is not given. Can you guess the acceleration now?
0.
Acceleration is 0. And then finally it stops at D. So at D, its velocity is 0 meter per second. And the displacement here, S1 is unknown, S2 is unknown, here T3 is unknown, A3 is not given, but displacement is given. It stops in 40 meters. And the total distance is given. The total distance is 640 meters.
640.
So supposed to calculate acceleration for each part, time taken for each part. So can I raise the question now?
Yes, sir.
Yes, sir.
For these type of problems, these are very common type of problems on uniformly accelerated motion. For these types of problems, if we solve this problem in parts. Like first of all, we will solve the path from A to B. We'll solve this thing first. From A to B, initial velocity is 0. From A to B, final velocity is 20 meter per second. From A to B, time is not given. Time is given, 10 seconds. Acceleration is not given. Displacement is not given. To calculate acceleration, we can simply use this equation. V is u plus a.
Yes.
So V is 20, u is 0, acceleration is unknown, and time is 10 seconds. So your A1 will be 20 by 10, that's 2 meter per second. This is A1, 2 meter per second square. Displacement from A to B is S is ut plus half AD square. S is ut plus half AD square. So S1 is u, which is 0, plus half acceleration, which is 2, into t square, which is 10 square. So your S1 comes out to be 100 from A to B. Then let's solve it from B to C. See, if A to B, if the displacement from A to B is this distance, A to B, if this is 100 meter and this is 40 meter, can you guess distance from B to C?
60.
500.
Distance from B to C, S2 is 640. The total is 640. Minus distance covered from A to B, which is 100. Minus distance covered from C to D, which is 40. So your S2 comes out to be 500.
Okay.
That is your S2, which is 500. Now, once you have S2, your acceleration is 0. Here, initial velocity is 20. You just need time. To calculate time, we can use this equation S is ut plus half at square. Displacement is 500. Velocity is 20. Time is t2. The rest is 0. So your t2 comes out to be 500 over 20. Gets cancelled out. Your t2 comes out to be 25 seconds. So time taken from B to C is 25 seconds. Next, let's solve from C to D. And we are solving from C to D. Your initial velocity u3 is 20 meter per second. Your final velocity v3 is 0. The displacement covered is 40 meters. You can easily calculate acceleration using this equation. V square minus u square is 2s. If we substitute, your v is 0, so that's 0 square. U is 20, which is 20 square. 2 into acceleration, which is a3. Displacement, which is 40. So minus 400 is 80 a3. Your a3 is minus 400 by 80. Your a3 is minus 5 meter per second. A3 is minus 5 meter per second. Similarly, you can calculate time. For time, you can use this equation. V is u plus 80. Your V is 0. Your U is 20. Your A is minus 5. Time is T3. So T3 will comes out to be 4 seconds. Is it clear?
Yes, sir.
Puzzle? Note?
Yes, sir.
Yes, yes, yes.
Okay, just note it down. There's one more type of numerical on uniformly accelerated motion.
Done.
Finished, sir.
So okay, I'm erasing it. Let's do one more question. Just one more question. One more type of question. The next type of questions are basically alphanumeric. In the next type of question, numerical value may not be given. In the next type of numerical value may not be given. So you're supposed to calculate in terms of unknown. Like a car deaccelerate, or not deaccelerate, it actually accelerates. A car accelerate from rest at a constant rate alpha for some time, after which it deaccelerate at a constant rate beta to come to rest. If total time elapsed is t seconds, then calculate first part. Maximum velocity attained by the car. Second, total distance traveled by car. In terms of alpha, beta, and t. Note this question, make a rough sketch and try to solve it. You have just 2 minutes. Just try to solve the first part. Try to write some steps. Make a rough sketch. So can I erase it? We have written the question. Na?
Yes, sir.
So just check your calculations if you have calculated anything. He's saying that a car starts from rest. If a car starts from rest, then what should be its initial velocity?
0.
It accelerates up to a point B. What's the rate of acceleration?
Alpha.
Rate of acceleration is alpha. So A1 is alpha. It accelerates for some, and the time, let's say the time interval is T1. For a time T1, it accelerates at a rate alpha up to point B. Means at B, there's some velocity V. Obviously, if the acceleration is positive, that means its velocity will increase, and the velocity is this V. And what happened next? It's again accelerate or it deaccelerate?
Deaccelerate.
Deaccelerate.
Acceleration means it's positive or negative acceleration?
Negative.
It's negative. That means it should be minus of beta. If it deaccelerates,
Yes.
acceleration is minus beta. And the time taken is T2. And what happened? What's the final velocity?
Zero.
It just deaccelerated or something else is given? Just check the question. Up to what velocity it deaccelerate?
It says it comes to rest.
Means finally its velocity is 0. Just check once. What is t? T is t1, t is t2. There is one t given in the question. T is t1, t is t2, or t is t1 plus t2. Just check what is t here. The t which is given in question. Is it t1, is it t2, or is it t1 plus t2?
T1 plus T2.
It's t1 plus t2. T is total time. Huh? The time taken from A to C. That total time is T. So obviously, out of 0, 0 and V, this must be the maximum velocity. So you're supposed to calculate this maximum velocity. Let's start from A to B. Fazil, what is initial velocity from A to B?
Zero.
0. What about acceleration?
alpha
Time t1.
t1
Final velocity is v. So we can use this relation, v is u plus at. Final is v, initial is 0, acceleration is alpha, time is t1. So here t1 is v by alpha, that is first equation. This is from A to B. Next, let's solve it from B to C. Sania, what is initial velocity from B to C?
0.
We are solving from B to C. What is the initial point? Initial point is A or initial point is B? Sania,
A.
we are solving from
B, B, B. Sorry, B, B, B.
what is velocity at B?
B. V.
So U2 is V. What about final velocity?
6.
It's 0.
0, sorry.
What about the acceleration?
Minus beta.
Minus beta, great. And the time is T2. Can you relate V minus beta in T2?
V square minus U square.
V is U plus A.
U plus
So your V is 0. Your U is, this is
0.
2 is U2, A2, T2. So that's V minus beta in. So we can write this as beta T2 is equal to V. So your T2 is V by beta. That's my equation number 2. Sania, how would you calculate total time? What is total time?
T1 plus T2.
T1 plus T2. And it is given as T, right?
Yeah.
It is given that total time is T. Just substitute one
We'll
in
substitute.
and get the value of V. That would be your final answer. Just substitute 1 into and get the value of V. That would be your final answer. Just make these substitutions and report your final answer in chat. Final answer, what's the value of V? Okay, Noor, yes, Noor, you are correct. Fazil and Sania, your answers.
Sir, I got beta by alpha.
Only beta by alpha.
Yeah.
There would be one t. There should
Yeah, is equal to t.
see if you substitute the values of t1 and t2 from 1 and 2. So t1 is v by alpha, right? Your t2 is
Yeah.
which is equal to t.
Mm.
You can take this v as common.
Oh.
You're left with 1 by alpha plus 1 by beta equal to
That's maybe is t.
what's the LCM?
Alpha into beta.
And you are left with
Beta
beta plus alpha equal to t.
to t.
So v is it's alpha beta t over beta plus alpha. Clear, Sania?
Yes.
Second part is your homework. I'm just writing the answer of second part. That would be your homework. The answer of second part is alpha beta t square by twice of alpha plus beta. That's the total distance. That's your homework. Just note it down. Then do the next topic.
That's
Yes, sir.
Let's erase it. And the next thing is displacement covered in nth second. The next numericals will use this concept, which is displacement covered in nth second. Displacement covered in nth second. So first understand what do we mean by nth second. When we say nth second, what does we mean? Say this is the first instant t1 equal to 0. That second instant of 1 second. Or I should better write this as first instant is t0, which is 0 second. Second instant is of 1 second. Next is 2 second. The next is third second and so on. Fourth second and so on. This interval from 0 to 1 is known as first second. When I say first second means interval is 0 to 1. When I say second, that means your interval is from 1 to 2, not 0 to 2. If I say 2 seconds, that means your interval is from 0 to 2. But if I'm saying second, that means it's just from 1 to 2. If I'm saying third second,
3 seconds.
2 to 3. If I'm saying fourth second, that means 3 to 4. If I'm saying 10 second, and what's the interval? Yes. Which interval is 10 second?
9 to 10.
Yeah. 10 second is interval from 9 to 10 seconds. If I'm saying nth second, Sania, then what is the interval? If I'm saying nth second,
And 2 seconds.
nth second means n minus 1
And
to
2 seconds.
n seconds, right?
Yes.
Is a fifth second, Sania. Which interval is fifth second? If I say fifth second, which interval is fifth second?
It's 4 to
Yes,
5,
it's 4 to 5.
4
If I
to 5 seconds.
20th second,
27 to 28.
20th.
20, 20 19 to 20 seconds.
And similarly, means we are subtracting one term, you know? If I'm saying 20th, that means one term less, 19 to 20.
1 turn.
In nth, then it should
Yeah.
be n minus 1 to n seconds. Is it clear?
Yes, sir.
Yes.
Meaning of nth second. One more thing. How much is the time interval in nth second? How much is the time interval for third second? 2 to 3. Time interval is 1 second. What is the time interval from fourth second?
1.
1 second. What is the time interval for nth second?
N.
1 second.
1.
Time interval is 1 second always. Time interval is 1 second. Interval is 1 second. It's 1 second. Okay. The next is, let's say if a body covers some displacement in 4 seconds. I write here S4. S4 is displacement covered in 4 seconds. When I say 4 seconds, it's not fourth, it's 4. What is the interval? Yes, Fazil, if I'm saying 3, it's not fourth, it's 4.
4 seconds. 0 to 4.
4 seconds means 0 to 4 seconds. So S4 is the displacement covered in 4 seconds. That means 0 to 4 seconds. S3, displacement covered in 3 seconds. Sania, what is the interval for 3 seconds?
0 to 3 seconds.
0 to 3 seconds. Now, if I draw these displacements here, then this is your S4 and this is your S3. This is your S4. This is your S4 and this is your S3. If I take one more displacement, if I write here D3, D3 is displacement covered in third second. So Noor, what is the interval third second?
So between 3 seconds and 2 seconds.
Let's say I'm writing D4. D4 is displacement covered in fourth second.
Then it's between 4 seconds and 3 seconds.
Between 3 to 4, right? So that's fourth second. 3 to 4. So that must be this one. If I draw it. This is it. This blue color. This is your D4. Noor, can you connect S3, S4 and D4?
It's a S4 minus S3 is equal to D4.
So your D4 is simply S4 minus S3, which is even clear from this diagram. Like from 0 to 4 is S4. From 0 to 3 is S3. So if I subtract S3 from S4, whatever be left is D4. Is it clear, Fazil, Sania? That D4 is
Yes. Yes.
So we can generalize this. If I'm asking you to calculate displacement covered in 4 seconds, so you can calculate displacement covered in 4 seconds in this way. First calculate displacement covered in 4 seconds, then displacement covered in 3 seconds. Similarly,
Yes.
Fazil, if I ask you to calculate displacement covered in 6 seconds, how would you calculate it?
S7 minus S6.
Not S7 minus S6.
Yes.
6.
S6 minus S5.
Okay, Sani, if I asked you to calculate displacement covered in 10 seconds, how would you calculate it? 10.
S10 minus S9.
If I ask you to calculate dn, which is displacement covered in nth second. Okay, I don't have much space left. Just note it down, then we'll do dn.
Hmm.
Just note it down, then we'll do dn.
Yes, sir, done.
Okay.
Turns.
Sania,
Yes, sir, done.
so can you guess how to calculate dn? dn would be displacement covered in n seconds minus.
N minus 1.
When I say Sn, then the time interval is
D.
if I say
One.
N, then the time interval is
1
0 to
it's 0 to n seconds. If I say Sn minus, then the time interval is 0 to n minus.
and
And this dn, displacement covered in n minus 1 to n seconds. So there are two methods to solve this numerical. You can either calculate S and Sn minus 1 using ut plus half at square and subtract them and get dn. Or you can use this direct equation, which is dn is u plus a by 2n minus. Just note it down, then we'll do some numericals on this concept.
done, sir.
Yes, sir.
We'll do two numericals on this concept. The first one is very straight formula based. I will expect you people to solve it. Like a body starts with velocity of 2 meters per second and accelerate at 3 meters per second square. Calculate first part. Displacement covered in 2 seconds or 3 seconds. Displacement covered in third second. Solve both the parts and report your answer in chat. Answers? Okay, Fazil, the first part. Okay. Okay, Noor. Let's check your calculations. Sania, your answers?
Sir, where is U?
Hmm?
Where is U initial velocity?
That's 2 meter per second. And this is the acceleration. Okay, Fazil. Sania, answers? Okay. That's first part. Huh? What's the second? And second one?
Sir, doing.
See, for the first part, you can simply use this relation. S is ut plus half AD square. So initial velocity is 2. And the time is 3 seconds. 3 seconds means 0 to 3 seconds. So this is simply 2 into 3 plus half. Acceleration is 3 into 3 square. So the displacement is 6 plus 27 by 2. So 27 by 2 is 13.5. It's 19.5. 19.5. Sania, is it clear?
Yes, sir.
In the second part, you're supposed to calculate nth second. So for nth second, you will use this relation. dn is u plus a by 2, 2n minus. So substitute the values. U is same. U is 2 meter per second. Your a is 3 meter per second square. But your n here is 3, third second. N is third second. When I substitute, d3 is, instead of n, just substitute 3. U is 2 plus acceleration is 3 by 2. 2 into 3 minus 1. So d3 is, it's 2 plus 3 by 2. It's 6 minus 1 is 5. So d3 is here 4 plus 15. 19 by 2. 9.5. Clear?
Yes, sir.
Just one more question on this concept. This was formula based only. So can I erase it?
Yes, sir.
Last question on uniformly accelerated question. Last type of question. A body covers 12 meter in second and 20 meter in fourth second. How much distance will it cover in 4 seconds after fifth second? 4 seconds after fifth second. No, sir. That would be very, very tough. Calculate first initial velocity, second part acceleration, then third part displacement covered in fifth second. Fifth second. Just note the question. The hint is you can use this equation in the first part. Dn is 12, your n is 2. In the second part, dn is 4, 20, n is 4. You will get two equations in u and a. Try to solve those equations, get the value of u and a. You have 3 minutes to solve this numerical. Then I will solve. Okay, Fazil, initial velocity. Okay, Fazil. Okay, Noor. Sania, did you solve it?
Sir, I'm doing great. I got.
You are doing. Okay, let's check your calculations. See, The displacement covered in nth second is it's u plus a by 2 2n minus 1. The data is given that displacement covered in 2 seconds is 12, second is 12 meter. So d2 is 12, which is u plus a by 2 into 2 into 2 minus 1. So 12 is u plus 3a by 2. So if I take LCM is 2, so you'll get 24 is 2u plus 3a. That's my first equation. This is 24 is 2u plus 3. Then it is given that 20 meter in 4th second. For d4, put n equal to 4 in this equation. Acceleration is half, okay? So it's 20 is equal to u plus a by 2, 2 into 4 minus 1. So this is simply 20 is u plus 8 minus 1, 7, 7a by 2. That is equation number. And if I take LCM, then it comes out to be 40 is 2u plus 70. That's my second equation. Just subtract 2 from 1 or 1 from 2. So that means 40 is 2u plus 7a. And here 24 is 2u plus 3a. It's minus, minus, minus. It gets cancelled out. So this is 4a, which is 16. So a comes out to be 4 meter per second. Sania, clear now?
Yes, sir.
Where were you making mistake?
In the substituting part.
Substituting part. Let's call this as equation number 3. If I substitute 3 in 1, then we will get 24 is 2 into u plus 3 into 4. So 24 is 2u plus 12. So yours 2u is 12 and u is 12 by 2. So initial velocity comes out to be 6 meter per second. 6 meter per second. Now once you have your initial velocity and acceleration, you can calculate displacement covered in 5th second, right? dn is u plus a by 2, 2n minus 1. Sania, how would you calculate displacement covered in 5th second? For d5, just mention the values.
6, U is
U is 6, right? What about a?
4,
4 by 2. What about
5,
5 minus 1?
minus
So it comes out to be, what was the final answer?
6,
Plus 2 into 9.
1.
18 plus 6 is? So that is the final answer, 24.
24.
Okay, just note it. So both Fazil and Noor were correct. Can we have an extra class tomorrow morning? Thursday is off, right?
Yes, sir.
Yes,
Which
sir.
time?
Can we keep it early morning, like around 9 a.m.?
No problem, sir.
Okay.
So on Thursday, we don't have school classes, huh?
Yes.
So can we do it at 9 a.m. tomorrow? It would be a 1 hour or 1.5 hour class only.
Okay.
Noor, Fazil.
Okay, sir. No problem.
So see you tomorrow at 9 a.m. So it's the numericals are finished. Tomorrow we just have to derive equations of uniformly accelerated motion, and then we'll start free fall.
Okay, sir.
Let's stop this. Sania, doubts?
No, sir.
No doubts. Okay.
Thank you, sir.
In few hours, I'm just sharing one more assignment. That assignment will have questions based on uniformly accelerated motion and acceleration. Try to solve
Okay, sir.
Thank you, sir.
it. Love this.
Thank
Thank
you,
you.
Thank
sir. Yeah, okay, sir.
Thank you.